Look at your feet for a second. Go ahead, look down. They're just sitting there, doing nothing dramatic, nothing that seems to deserve much attention. But here is the strange thing. Your brain has spent years, possibly decades, building a nearly perfect model of what it feels like to move forward. Every step you've ever taken, every corridor you've walked down, every sidewalk you've shuffled along at half speed while staring at your phone, your nervous system has cataloged all of it. It has a file deep in its archives labeled something like forward locomotion trusted, verified, on autopilot. And because that file is so well worn, so deeply grooved into the circuitry of your spinal cord and your cerebellum, your brain doesn't really think about walking anymore. It just does it. You are, in the most literal sense, running on a program you forgot you wrote. Now, what happens when you flip the script entirely? What happens when you turn around, point your heels in the direction of travel, and just walk backwards? Something remarkable occurs. Something your biology was not quite expecting. The file gets thrown out the window, the autopilot shuts off, and in the space of about 3 steps, your entire nervous system wakes up as if someone just splashed cold water on the face of a sleeping machine. What follows is not just a curiosity. It is a window into some of the deepest physics and engineering principles that your body runs on every single moment of your life. Let's start with the brain, because the brain is where this story gets immediately strange. Neuroscientists have known for a long time that your visual cortex, the part of your brain at the very back of your skull that processes what you see, is wired, architecturally, for forward motion. The neurons that track what's called optic flow, the way the world seems to stream past you as you move through it, are tuned to expect objects to grow larger as you approach them and shrink as you move away. When you reverse direction, that entire system is suddenly receiving the wrong feed. Objects are doing the opposite of what the program predicts. The brain, being the extraordinary prediction machine that it is, doesn't just passively receive this information. It panics, quietly, and starts allocating far more processing power to figuring out what is happening. This is why walking backwards feels so cognitively effortful. It genuinely is. You are forcing your brain to run a calculation it has never optimized. Here is your first golden number to hold on to: 0.1 seconds. That is roughly how long it takes for your visual cortex to process and relay positional information to your motor cortex, the part of your brain that actually tells your muscles to move. In forward walking, this lag is almost irrelevant, because your brain has learned to predict what's coming next. It sends the movement command before it has even finished processing the visual information, using the model it has built from thousands of hours of forward locomotion. When you walk backwards, that predictive shortcut is gone. Your brain has to wait for the full 0.1 second data packet. This is why backward walkers look so tentative, so careful. They are operating in a time regime that feels almost geological by brain standards. They are living 100 milliseconds behind the present moment, navigating purely on reaction. But now let's drop down from the brain and talk about something far more mechanical: the physics of your skeleton. Your body, from an engineering standpoint, is a remarkable compression structure. Your spine is not a single solid column. It is a stack of curved bones separated by discs, designed to absorb and distribute force the way a suspension bridge distributes the weight of traffic. In forward walking, the heel strikes the ground first, sending a shockwave upward through the ankle, the shin, the knee, and into the lower back. Your body has evolved a set of elegant shock absorption strategies for exactly this sequence. The arch of your foot collapses slightly, a process called pronation, to act as a biological spring. Your knee bends in a precisely timed flex to catch the impulse. Your hip flexors engage to keep your center of mass from toppling forward. When you walk backwards, this entire choreography reverses. Your toes hit the ground first. The arch never gets to do its spring act in the same way. The knee has to flex in the opposite phase of its usual cycle. And critically, the muscular load shifts dramatically to your glutes and hamstrings, the muscles at the back of your legs, which in forward walking are largely passengers for the final push-off phase, but in backward walking suddenly find themselves doing the majority of the navigational heavy lifting. This is not trivial. Studies in rehabilitation medicine have found that backward walking can reduce the compressive force on the kneecap, the patella, by a measurable percentage compared to forward gait. The reason is beautiful in its simplicity. When you walk backwards, your shin bone tilts backward rather than forward, which changes the angle at which your quadriceps muscle pulls on the patella. Less angle, less compression force on the joint surface. It is the same principle as changing the angle of a pulley in a mechanical system to reduce the load on a cable. Your body is a machine, and the angle of your bones are its levers. Here is the second golden number, 30%. That is roughly how much the muscular demand on your quadriceps decreases during backward walking compared to forward walking, while the demand on your hamstrings and calves increases by a comparable amount. Physical therapists have used this asymmetry deliberately, prescribing backward walking to patients recovering from knee surgery precisely because it lets them exercise the leg without loading the very joint that was repaired. The machine has a back door, and we've learned to use it. Now let's talk about the engine running underneath all of this. Your cardiovascular system. Your heart is, at its core, a pressure pump. It generates hydraulic pressure and uses that pressure to push blood through a network of pipes. Your arteries, veins, and capillaries. That, if you unraveled them and laid them end to end, would circle the Earth roughly 2.5 times. This is not a metaphor. That is the actual estimated length, about 100,000 kilometers of biological plumbing inside a single human body. The heart achieves this feat by cycling through a contraction roughly 60 to 100 times per minute at rest, a tempo so consistent and so deeply physical that musicians have long used the heartbeat as the intuitive baseline for musical rhythm. Here is what walking backwards does to this pump. It demands more. Not enormously more, but measurably, interestingly more. Because backward gait requires greater muscular stabilization, your core, your hip stabilizers, your proprioceptive muscles all engaging at higher intensity to compensate for the brain's reduced predictive confidence. The metabolic cost of covering the same distance walking backwards is significantly higher than walking forwards. Research has measured it at between 20 and 40% more caloric expenditure for the same pace and distance. Your slow burning cellular fire, the process called oxidative metabolism, where your mitochondria combine glucose and oxygen to produce ATP. Your body's universal currency for movement simply has to run hotter. More fuel in, more heat out, more demand on the cardiovascular supply chain that feeds oxygen to working muscles. This brings us to something even deeper: heat. Your body is, thermodynamically, an engine. And like every engine that has ever existed, from a car combustion chamber to a nuclear reactor, it generates waste heat as a byproduct of doing useful work. The laws of thermodynamics are not optional. Your cells are not special. When you walk backwards and your metabolic rate climbs, your body's internal temperature rises, and your thermoregulatory system kicks in with a response that is as elegant as anything in engineering. You begin to sweat. Sweat, which is mostly water with trace electrolytes, evaporates from your skin surface, and in evaporating, it carries heat energy away from your body at a rate determined by the physics of phase transition. The water doesn't just move, it changes state from liquid to vapor, and that state change requires energy, which it steals directly from your skin. You are, in the most literal physical sense, cooling yourself via thermodynamic phase change. A steam engine runs on this principle in reverse. You run on it forward. The third golden number is 37 degrees Celsius. The target your body thermostat defends with extraordinary ferocity to within a fraction of a degree for your entire life. Your hypothalamus, a small walnut-sized region at the base of your brain, acts as the thermostat itself, receiving temperature signals from receptors all over your body and dispatching instructions: dilate blood vessels to radiate more heat through your skin, activate sweat glands, or, if you're cold, trigger shivering, which is nothing more than your muscles doing rapid, tiny contractions to generate heat as a byproduct. Walking backwards, by raising your metabolic rate, forces the hypothalamus to respond more actively to maintain that 37-degree set point. You are, in this sense, stress testing the thermostat. Let's now follow the electrical wires. Your nervous system, the brain, the spinal cord, and the vast peripheral network that reaches into every corner of your body is a biological telecommunications network, and it runs on electrochemistry rather than copper wire. Each neuron generates a signal by pumping sodium and potassium ions across its membrane in a carefully sequenced surge. The action potential. which travels down the nerve fiber at speeds ranging from about 1 meter per second in slow sensory fibers to nearly 100 meters per second in the fastest motor fibers. These wet electrical wires connect every muscle in your body to the processing centers in your brain and spinal cord, and they are what make coordinated movement possible. When you walk backwards, the proprioceptive load on these wires goes up dramatically. Proprioception, your body's sense of where it is in space, depends on mechanoreceptors embedded in your muscles, tendons, and joints, constantly reporting their status upward through the spinal cord. In forward walking, your brain uses its forward gait model to filter and predict these signals, so the spinal cord doesn't have to relay everything upward for conscious processing. A lot of the fine motor coordination of forward walking actually happens at the spinal cord level, not the brain. It's a local reflex loop, cutting out the middle manager. Backwards walking breaks this system open. Without the predictive model, more signals get escalated to conscious processing. The cerebellum, your brain's dedicated motion processor tucked at the back base of your skull, fires with higher frequency. It is recalculating balance with every step rather than trusting a script. This increased cerebellar demand is, researchers believe, part of why backward walking has shown measurable effects on spatial memory and cognitive flexibility. You are not just exercising your legs. You are renovating the neural architecture of how you navigate space. The fourth golden number is 6 weeks. In multiple studies, sustained backward walking practice over roughly 6 weeks has produced measurable improvements in forward walking speed and balance in older adults. The hypothesis is fascinating. By forcing the nervous system to build a new motor program for backward locomotion, you are in effect teaching it to be more adaptable, more plastic, more capable of handling unexpected perturbations in any direction. You are not just strengthening a muscle. You are expanding the repertoire of your motor cortex. You are widening the program library. Now let's step back even further, way back, to the scale where biology meets cosmology. Your body, this remarkable ambulatory machine, is made of elements forged in the cores of stars that died before our sun was born. The iron in your blood, the calcium in your bones, the carbon chains that form your DNA, all of it was assembled in stellar furnaces and scattered across the galaxy by supernova explosions. You are, in the most literal chemical sense, stardust that learned to walk, and not just to walk forward. The fact that you can choose to walk backwards, that you can deliberately override an automatic system, wake up a sleeping network, redistribute mechanical loads, reroute sensory processing, and stress test a thermostat that keeps you within a fraction of a degree of the temperature you need to survive. This speaks to something profound about the nature of living systems. You are not a passive passenger in a biological machine. You are the machine and the engineer simultaneously. You can, at any moment, take the wheel from the autopilot and see what the vehicle can really do. The universe, as far as we can tell, trends toward disorder. Entropy is the name physicists give to the tendency of things to fall apart, to spread out, to lose structure. Yet here you are, a temporary local reversal of entropy, held together by the slow, burning fire of your metabolism, navigated by the electrical intelligence of 86 billion neurons, cooled by the physics of phase transition, stabilized by the geometry of your skeleton, and capable, right now, of doing something as beautifully strange and illuminating as turning around, putting your heels forward, and walking in the wrong direction down the street. The universe makes stars. Stars make atoms. Atoms make bodies. And bodies, when they are paying attention, walk backwards and discover something real about how everything works. Try it tomorrow. Find a clear path. Turn around. Take 10 steps backwards. Feel the cognitive effort, the muscle unfamiliarity, the slight edge of alertness. That feeling is your nervous system waking up. That feeling is physics, chemistry, electricity, and thermodynamics all renegotiating their usual deal. That feeling is you, briefly, clearly, and wonderfully aware of the machine you live inside. And what a staggering, beautiful, improbable machine it truly is.